14 million pounds of steel stood in the Mahoning Valley of eastern Ohio, and for over 40 years, it never stopped moving earth. This was the Silver Spade, a Bucyrus-Erie Model 1950B power shovel, built in 1965 for the Hanna Coal Company. It was not the largest stripping shovel ever built. That title belonged to the Marion 6360, known as the Captain. But the Silver Spade held a distinction that mattered more to the men who ran it. It was the last of its kind, still working, decades after every comparable machine had gone quiet. To understand why the Silver Spade survived as long as it did, you have to understand the specific engineering choice buried inside its frame, a choice that only one other machine on Earth ever shared. By the mid-1960s, stripping shovels had reached a scale where the standard crowd system was becoming a liability. The crowd mechanism is what forces the dipper handle and bucket forward into the bank, pushing the teeth into compacted earth and rock. On most shovels of this era, that motion came from a straight cable crowd system, a simple and proven method, but one that placed enormous strain on the dipper handle at extreme bucket sizes. Hanna Coal Company wanted a shovel capable of moving more than 300,000 pounds of earth in a single bite. At that scale, engineers at Bucyrus-Erie faced a mechanical problem their existing designs were not built to solve. That demand did not come from nowhere. By the mid-1960s, the United States was burning coal to generate electricity at a rate the country had never seen before. Post-war industrial growth, the spread of home air conditioning, and the steady expansion of the national power grid had turned coal-fired power plants into the backbone of American electricity. Nationally, the majority of coal mined was no longer heating homes directly. It was being shipped straight to power plant boilers. Hanna Coal Company, by this point folded into the larger Consolidated Coal Corporation, held tens of thousands of acres of strippable coal land across eastern Ohio's Harrison and Belmont counties. The scale of what the company was planning was not modest. Within a few years of the Silver Spade entering service, Hanna would open a single mine in the Egypt Valley expected to produce 20,000 tons of coal a day, with reserves the company projected would last 30 to 40 years. Feeding that kind of continuous output required removing the earth and rock, sitting on top of the coal seam, faster than any shovel of the era was built to do. A machine that stalled, or one whose dipper handle failed under repeated stress, did not just cost Hanna a repair bill. It cost the company thousands of tons of coal a day that utility customers were already counting on. This was the pressure sitting behind Hanna's request to Bucyrus-Erie. They were not asking for a bigger machine because bigger was impressive. They were asking because the economics of feeding a nation's power plants had outgrown what a standard shovel could deliver. The solution came from an unlikely place. Marion Power Shovel, based only a few hours away in Marion, Ohio, had developed a different approach entirely: a knee-action crowd system. Instead of a straight cable pulling the dipper handle forward, the knee-action design used a jointed, hinged mechanism, closer in principle to the way a human leg extends. This allowed the crowd force to be applied more efficiently across the full range of the digging motion, reducing the peak stress at the extremes of the stroke. For a shovel the size Hanna Coal was requesting, this was not a minor refinement. It was the difference between a machine that could survive years of continuous, maximum capacity digging and one that would tear itself apart from repeated stress at the joint. There was a problem. Marion held the patent. Bucyrus-Erie and Marion Power Shovel were direct competitors, manufacturing the largest excavating machines in the world for the same handful of coal companies across the American Midwest. In most industries, a competitor holding the exact patent you needed would end the conversation. But the scale of what Hanna Coal was asking for pushed both companies into a rare position. Bucyrus-Erie needed the knee-action crowd design to build a machine at this size. Marion, in turn, wanted access to a cable crowd system technology that Bucyrus-Erie controlled. The two companies arrived at a direct patent exchange. Bucyrus-Erie licensed the knee-action crowd from Marion, and Marion gained rights to use Bucyrus-Erie's cable crowd system in return. Only 2 machines were ever built under this arrangement. The Silver Spade was the first, completed in 1965. Its sister shovel, built in 1967 for the same customer, was named the GEM of Egypt, standing for Giant Earth Mover. Every other stripping shovel Bucyrus-Erie ever produced used the company's standard crowd system. These 2 machines were the only exception in the company's entire production history. The finished machine was difficult to comprehend at ground level. The Silver Spade stood 220 feet tall to the top of its boom, weighed 14 million pounds, and moved on 8 sets of crawler tracks. Its bucket held 105 cubic yards, capable of lifting 315,000 pounds of earth and rock in a single pass, then swinging 180 degrees to deposit that load up to 390 feet away. 14 main digging motors, drawing power through a 7,200-volt trailing cable, could generate a combined peak output of 13,500 horsepower. And despite this scale, the entire machine was operated by a single person, seated in a cab far above the pit floor, controlling every function of the shovel through 2 hand levers and a pair of foot pedals. The knee-action crowd was not a visible spectacle. It did not announce itself the way the size of the bucket or the height of the boom did. It worked quietly. Inside the joint connecting the dipper handle to the shovel's saddle block, absorbing stress that would have shortened the working life of a conventional design. Over the following 4 decades, that quiet mechanical advantage became the reason the Silver Spade kept running long after machines of comparable size had been retired. The Silver Spade began operating in the Mahoning Valley in November of 1965, stripping overburden to expose the coal seams beneath. Its work was not glamorous. It performed the same motion, day after day, year after year. Dig, swing, dump, return. But the cumulative scale of that repetition became difficult to comprehend. Over its working life, the Silver Spade moved 607,226,370 cubic yards of material. That figure is more than double the entire volume of earth excavated to build the Panama Canal. By the 1990s, the era of the mega shovel was ending. Drag lines and hydraulic excavators had taken over most large-scale stripping operations, offering greater flexibility and lower operating costs. One by one, the great stripping shovels of the 1960s were retired and scrapped. The Marion 6360 went first. The Gem of Egypt, the Silver Spade's own sister machine, stopped operating in 1988 and was scrapped in 1992. By the early 2000s, the Silver Spade was the last stripping shovel of its scale still working anywhere in the United States. It kept digging until April of 2006, when the machine finally broke down. By then, it was simply no longer economical to keep repairing a 41-year-old machine built around parts and systems that no manufacturer still produced. Consolidation Coal Company, which had inherited the shovel through a series of corporate acquisitions, made the decision to retire it permanently. What happened next was not purely a mechanical story anymore. A group called the Harrison County Coal and Reclamation Historical Park, founded in 1992 specifically to preserve machines like this one, began organizing an effort to save the Silver Spade from the scrapyard. The plan was to purchase the shovel and turn it into the centerpiece of a mining museum, preserving both the machine and the labor history it represented. The asking price was $2.6 million. The group launched pledge drives and fundraising campaigns that drew national attention. They raised roughly a third of what was needed. In January of 2007, a salvage company began cutting the Silver Spade apart. On February 9th, the boom, the same 200-foot structure that had swung 300,000 pounds of earth for 40 years, was brought down using explosives. By the 1st of March, most of the machine had been reduced to scrap steel. The knee-action crowd system that made the Silver Spade possible was never widely adopted beyond these two machines. It solved a specific engineering problem at a specific scale for a specific customer, using a specific patent-sharing arrangement between two competitors who rarely cooperated on anything. When hydraulic systems replaced cable-operated shovels across the industry, the entire category of engineering the Silver Spade represented became obsolete almost overnight. There was no third generation of knee-action shovels. There did not need to be. What remains is the arithmetic. 600 million cubic yards of earth moved 105 yards at a time by a machine that outlived every competitor built to do the same job. The Mahoning Valley, where it once worked, has long since been reclaimed, graded, and replanted. The 7,200-volt cable that once fed it is gone. What is left is a number difficult to hold in the mind at once, and the quiet mechanical detail hidden inside a single joint that made all of it possible.